Okay, so I will create a program that will meet the requirements of our latest project, which is 3 controllers which communicate to each other. They all turn off, they all shut down their process if one of them shuts down their process. So I'm looking at the state diagram that we drew on the board, and it looks like there's 3 states that we go in. And I know we also talked in class about a parallel process that also runs to track if one of the systems turns off, how to respond to that. So let's do one thing at a time. I'm looking at the description here, and it says that there's a status tag in each controller. So let's do this first. I know that I'm going to have 2 additional controllers in my project, so I'm going to show you how to add that first. What you do is you right click here where it says Ethernet, add a new module. You'll notice this processor is 1769-L16ER, the L16. I need 2 more like that. So I'm going to click here and type 1769, and there it is. I'll create that module. I'm going to call this one. I have my target is going to be the .18 system. So we need an 11 and a 15. So this will be called node 11. Okay, at IP address .11. And I'm going to create another one at node 15, which is .15. Okay, so now I have 2 additional modules, 2 additional Ethernet modules added to my project. Okay, I need that so in the messaging instruction, I can select that pathway and complete the message instruction setup. So the next thing I'll do is let's go to controller tags, and I know that I need a tag called status. Okay, so I'm going to create a tag for status. It's going to be a dent, a double integer, so that's good. And there it is. And that's all I want for right now. So let's go back to the main program and the main routine. And we said in class that we would use the first pass coil to reset the system. So let's do that. Right here, I'll have a closed first pass. Okay. And I'll right click, create a new one, and that's going to be a base tag and at the controller level. Okay. Then I will have a move instruction. I will move a 0 into a tag called state value. And I will need to right click that, create a new state value. It's a dent as well. Okay. Last line will be the first pass coil. So let's do that. Okay. Now we have to fill in the blank. So let's add some blank lines here. I'm going to move this down. If I'm in state 0, so we'll put an equal here. So if state val equals to 0, I need to look for the start push button. So that's a start, an open contact called start. Now I'm going to create that. Normally I would create an alias data type because I would like to connect a push button to it. But since I don't see a push button connected right now, I'm going to leave it as a base tag so I can toggle it on and off. Okay, so there's start. If I press start from state 0, I go to state 50. Okay, so I'm going to copy this instruction and I will paste it here. So a 50 goes into state val. So now I just copy and paste some more. So if I'm in state 50, and the aux input turns on, so I'm going to show that as an open contact. I'll call it AUX, and that's a new AUX. If that happens, I go to state 100. So I'm going to copy this, paste it here. Notice when I click on this contact and paste it, it drops it to the right. So that's just something that saves a little time. If I'm in 100 and I press the stop button, I go back to 0. Or if aux turns off. So I'm going to go copy paste. If I'm in 50 and not 50, if I'm in 100 and aux turns off. So here's AUX. Or if stop is pressed. So what I'll do is, since these are virtual push buttons, I will make it an open stop. So when I toggle it, it will be like I pressed the stop button. Normally, this would still be fine because the stop push button is normally closed, so you would put a closed contact right here. Okay, and that would detect when you press it. So this would change to a closed, an examine off contact if I had a real switch connected. So let's copy this one and paste it. And I go back to 0. Okay. So startup goes to 0, 0 press start, go to 50, 50 press aux turns on, I go to 100, 100 I hit stop, I go back to 0, 100 I turn off the auxiliary switch, I go back to 0. So the auxiliary comes off the motor starter. If the motor starter trips out because the motor overloaded, that should turn off our system, and that would take care of it right here. Okay, and that's about it. So let me set up the messaging instruction for you, and there will be 2 of them because I have 2 nodes that I'm reading data from, and it's a polled instruction, so that means it happens periodically. And let's set up, let me add a couple more lines here. So let's add a couple of timers that just generate a pulse, and we'll stagger the time on each one of those so that it doesn't occur at the same point in time. So we'll do a couple of TONs here, a couple of on timers. This one can be pulse 1. This can be pulse 2. Create a new pulse 1. It's timer. New pulse 2. Also timer. And preset on this one. Let's do every half second on this one. This one can be every 600 milliseconds. Okay. Well, in fact, let's stagger that a little bit more. How about 627? What I'm trying to do is make sure that they never coincide at the same time. And every half second, 2 would be 1, 3 would be 1500, 4 22,000, 5 would be 2,500, and 6 would be 3,000. So if I had put a 600 on the bottom one, after 5 pulses, I would be at 3000. And technically, I'd be trying to fire the message instruction at the same time. That's not a problem though, because the way the system runs, if you trigger a message instruction, it loads it into a queue to be processed. So even if you fire 2 at exactly the same time, the processing would happen, one after the other. So it's not a problem. I just don't want them to fire at the same time. So this will be not pulse 1, dot done. And then here will be not pulse 2, dot done. So this times for 500 milliseconds turns on and resets itself the next scan. So right here, I'll use that bit, the dot done bit, to trigger my message instruction. Messaging is an input instruction. The control, the tag for the message control, we'll call this one node 11 CTRL. Okay. Node 11 control. I'm just going to create that. On the triple dots here, I'm going to do a data table read from 11. So the source element will be status. Okay. Destination will be a new tag known as status underscore node 11. And it's a dent as well. So make sure your data types align. They have to be the same or it won't work. Create that. My communication tag, the tab, I want to set this to node 11. And that's it. That's all I have to do. So I configure the operation here. I have one element, which is one tag. My COM is set on the path here. Let's just say OK on that. All right. And I want to copy some of this down. This is going to be pulse 2. And this message over here is going to be node, I'm on 18, so node 15. Let me just double check. Yeah, node 15. CTRL. I'll do a new, create the tag. On my triple dots, I go to a read as well. The tag is called status. My destination will be status node 15. My pathway will be node 15. That's it. Oh, I forgot to create that tag. There we go. So this should run by itself. Let's download this to node 18. So I will click on the network who is. I'll activate my driver. And I'll wait a few seconds. I'm looking for 18. Here's 18. And I will download to it. Okay, I'm checking to make sure my switch is in remote mode, and it is. So I'll download this to 18. And we'll watch it run. I don't think the other controllers are set up at all. Probably get errors on both of these message blocks, but let's just try it and see. Let's go to run mode. So let's see, we're in state 0. See, I've got 2 error messages on my message blocks because the tags are not set up in those remote stations, so there's nothing for it to read. The pulse timers are running, so I'm trying to get data, but it's not responding. Let's toggle the start push button. You can see we go to state 50. If I turn that off, it doesn't change anything, but if I press aux or activate aux, I go to state 100. And if aux turns off, you see how it went back to 0. So let's get it back up to state 100. So what's going on here is the pump would turn on, the aux would seal in, and if I press stop down here, I go back to 0. Okay. So the state diagram looks good. You know, one thing I can add here, I'm going to add it at the very bottom. Let's add a rung down here for pump. Pump. Oh, there's some other things I've left out as well. The counter that ramps up. We're not using that, so I'm going to just not put it in this video. But we do want to turn on the pump if it's in state 50 or 100. So let's add a coil called pump. And again, it's going to be a base tag because I don't really want to turn an output on. But you know, let's turn an output on. Let's go ahead and edit that just to show you how to do it. I have to go offline now that I've messed up. What I'll do is go to pump, I'll edit pump properties, and I'm going to change that to an alias tag. It's going to be an alias for local output number 15, let's say. Okay. So what that does is it assigns the name pump to that output bit. And you notice how it changes the structure here. So if the pump is supposed to turn on, the actual relay in the controller turns on, and it would energize a motor starter. So I'm going to have a couple of compares. I'm just going to copy this one, and we'll paste it right here. And I'll branch around this point. I'll copy this again and paste it right here. And change it to 100. Then I'm going to download again. You know, I probably could have gone into program mode instead of remote run and changed the properties on the tag. But normally when you create a tag, once you create it, you can't change the properties while you're online because that would cause trouble for everything that's using the tag. Let's just watch it and see what it does. Go back to run mode. Let's put it in state 50, and the pump is on. And the actual indicator light is on, so I know that output 15 is energized right now. So I've tied this to a real external device, which is a relay. If I had a motor starter running the real pump, I would probably I would use an external 24-volt relay and turn that on with the PLC and let the relay turn on the motor starter. I don't like the idea of any kind of coil current rushing through the relay contacts inside the controller. They're expensive to fix. If I have an external relay and burn it up, that's $20 or so versus the cost of a new controller or getting it fixed, which is high. Okay. So here's the basics of it. Let's see if I can create a new project while I'm running this one, and I'm going to call it node 11. Okay. What I'm trying to do here is go ahead and set a status tag in node 11 that's something so I can see if it's reading correctly. Okay. Yeah, let's save the changes to this project. Controller node 11. I'm gonna go ahead and create a new module. Actually, I don't have to. All I really want to do is make a controller tag called status. And let's load a number into it, like 77. And I'm going to download this to, we have to set a pathway. We're going to find 11, download to it. I can't see 11, it's on the other side of the classroom, but I know I'm talking to it because it's going to 11. Put it back in run mode. So I have a value of 77 in that. Let's save this, and we'll open this program, which is the one I had up before. Let's go online with controller 18, and let's see if at least the node 11 messaging instruction is working now. Let's have a look here. See how this is done now? It's done. So it's actually working. Let's look at the controller tag database, and let's look at these two status values. And sure enough, node 11 now has a 77 as its status. So I'm reading that across the network. Let's do the same thing for 15. Let's open this program, which is node 11, and let me change the properties on this. I'll make it node 15 here. So I've changed the name of the project, and let's look at the tags. Let's download this project to node 15, which is right there. It's not really much of a project. I'm just creating a tag, but I need it there for the message block to work correctly. So it's going over to 15. Yep, go back to run mode. Now I'm going to close this one and open my original project that I started with. Let's do it from here. And I'm going to go to controller tags, and I need to go online with it. And sure enough, now I've got the same number in both remote nodes. You know, of course, they'll be different in real life because they're both doing different things. But we're only looking at status bit 0, which is the run stop bit. So, you know, if we were to change it at that station, we would see the change reflected here. The only thing I can add to this is, you know, I skipped over it earlier. That is the pump routine, which is really a counter. I think every 100 milliseconds it counts up. Let's go ahead and throw that in here real quick so that you can see that as well. I'm going to have a pulse timer. I'm going to have a counter, and I'm going to have a reset. So let's do it real quick here. We'll do a timer. I'm going to call this pump ramp. That's my timer. And it's preset of 100. So it will count 10 times per second. The bit is going to be a not pump ramp.dn. Okay. Right below that, I've got a counter. And that goes over to CTU. The counter name can be ramp. Ramp's a good name. Got a preset of 101. Okay. And here I'm going to say ramp.dn. And there's a reset, an RES. So I'm going to reset ramp. So when I get to 100, the next pulse that comes over will technically move it to 101, but that will also reset it back to 0. So technically, the value of ramp only reaches 101 for this amount of time, which is very brief, like a few microseconds or so. Then it goes back to 0. So it's interesting to watch a trend of ramp.acc. So let's add one more rung here, and I'll show you what that looks like. And I'm going to do a compare. I just need those numbers here. So this will be ramp.acc and ramp.acc. And as a coil on that rung, I'm going to put a no op so it doesn't do anything. I will accept all those edits, and there goes the ramp. So let's watch it for a second. And then what I'm going to do is right click on it, trend it, and just let the trend run. So trending is great. It's like a graphical technique. You can see the values ramp up, and notice the highest value that the system goes to, which is 100. Let me change the properties on this just a little bit. On the sampling, I'm gonna have to stop it. Let me stop it. Change chart properties, x-axis. Let's make it let's say about 30 seconds wide. And then on the sampling, we're taking a lot of samples. Let's do a 10-minute sample, and we'll do 50 milliseconds. So what I'll say about the sampling is that the sampling should occur twice as fast as the signal that you're monitoring. So if it's a 100 millisecond period on the timer, we should do every 50 milliseconds. So let's apply that, let's run it, and let's watch what happens here. So I left the y-axis on auto scaling. I did that on purpose because it turns out that the program will catch the highest value of, in this case, ramp.acc and put that on the y-axis. So see how the value ramps up and then drops to 0 and ramps up. If I stop that and click on it, you can see the value here of the ramp at that point in time. So let's see. It's in blue. You can't hardly see it. Let's change the color from blue to something that I can actually see. How about that yellow? 73, 79, 89, 100, 2. So you can use the mouse to drag your sample line back and forth. And sure enough, because we set a preset of 101, as soon as it hits 101, it drops back to 0, and the program never sees it go above 100. So it's a very useful tool. What I did was I created a trend, and you can see it's right here. So if I double click on that, I can pull it up. It's very handy to use the trending tool. It lets you see things that are happening too fast for the screen update. Because you notice how the screen update is jumping in big increments, just the way the screen works. So that's about all I want to put in this. It's probably running late anyway, so I'll stop.